Hello, my name's Dr. Randy Price and I work for the LSU Ag Center. I want to go over some stuff today about, we get a lot of questions about how to actually get some quantified data out of typical red, green, and blue drone imagery, and it works for NIR and other types of imagery too. And that's often a question that researchers have, or people working for a researcher trying to report back on, how well some plot work did, or even see good and bad areas in a field. Farmers can use this to try and get a quantitative idea of different areas in their fields and things like that. So what we want to go over is a free program that you can get that will allow you to do that. And this program is ImageJ. When you download it, this is a free program, totally free. It'll put it in a folder. You can drag that folder out on your desktop, and from there you can start it like this. Keep going to ImageJ, and here's the program right here. Now, there's a lot of other plugins and things like that that you should leave in there. So we start ImageJ. Sometimes it'll take a little while for this program to start up. You can kill this folder. And this is the basic program right here. What this program is going to do is this program is going to allow you to load in imagery from drones, either orthomosaics or individual images. And then it's going to allow you to box that, different areas of that image. And when you box those images, you can then look at the histogram or some other options to see the actual red, green, and blue colors for those areas. So let's see an example of that. So from here, I'm going to go File, New, or Open. We got a folder here where we have a bunch of images in it. Now, you can either choose individual images or you can do an orthomosaic. A lot of people think you got to put images together to get data. No, you don't have to. You can pick individual ones, but if you do multiple individual ones, you should make sure the camera settings stay the same. Most of the time when we do taping with a drone, we actually put the camera in a manual mode so that things aren't changing as we're going across the field. So let's pull one up here that has some of the plots in it. Here's one right here. So this shows you some plots. This is the disease plot where they had corn that was under stress with certain diseases. And then they had corn that had been sprayed with either the fungicides or whatever the chemical was to protect it from that disease. So you can see that we have good plants and then we have bad plants. So you as a researcher might say, well, I'm trying to report on how much, this chemical helped keep that plant safe from whatever disease was traveling through here. So, and they want more than a photo. You can do a photo. That's a pretty nice way to illustrate things too. But in the report, they may also want some numerical data, to prove how much better one was than the other. So an easy way to use this program or get that data is load this in ImageJ, go over here to Processes, go over here to Analyze, hit Histogram, and you'll see this little feature come up. And you can drag it over here where it's not on top of your image because you're going to need to use both. Now right now I'm getting a histogram of the whole image, and I probably don't want that because I probably want to look at a plot or some area within that image. So what you can do is you can go up to this little box here, punch it. I have circles, polygons, things like that. Typically it's easiest to use the box. I'll show you some stuff later on about, polygons can get hard to use, so you may want to use a box and then rotate the image or something to make it match. So then I can highlight. Here's a good plot of that corn. I can highlight it like that, and then from there I can punch this over to red, green, and blue. And voila, these are the mean values right here in the middle for that whole plot. Now some people ask me like, well, why can you use the mean value? Well, that is the mean value, and that could have been NIR too if your imagery had an NIR in it. That is the mean value for everything within this plot. So that is probably a good average of your plot or your area within your field for that numerical value. So one way is you could take this data and just hand read it or write it on a piece of paper as you go through here, selecting different areas, things like that. There is a different way to do this, which is kind of nice. You can kill this. You can go over here to Analyze, plug in, Analyze, RGB measure. So what this is going to do is this is going to record each time. And for me, I went in here and I put in that the F1 will make this results analyze reoccur. I can go in here and I can drag this box around to different areas, and I can hit F1 and this will put the new data right below it. And why that can be faster is now I don't have to handwrite this data. I can just select this data, put it over in Excel, and I can then do certain types of indice calculations, things like that, or get those quantitative values. So let's see a demonstration of that. Well, the first one when I started it was the first box. That's why you should always put the first box over where you want to start. If you don't, you can just strip that data out. So then I can do two things here. One is I can grab this box, which you think grab the side, but you actually grab it in the middle. I don't want to change the size of the box, so be careful not to delete your box, because changing the sizes could have a little bit of bearing or a little bit of effect on your analysis, depending on if you get more or less soil and things like that may be in between the crops. So now I put it over here. Now for me, and you can go do this on your own, you can go in here and set this up as a script so this will run. So every time I hit F1, I get the new data. So if you looked, the red of the green spot was 98.6, and this is a RGB image. That's a JPEG. So the values for each wavelength are going to range from 0 to 255. So this one's at 98. Now, this newer area that I selected, which is more burnt, it has the disease that's rippling through it. It's not as healthy. The red value is now 114. So that's the new one. So some of you may say, well, what does that mean? Well, if you study a little bit about chlorophyll and how plants grow, they actually absorb the red. Okay, the plant's green, so that's somewhat reflected, although it is absorbing the green also. But the red is one of the main wavelengths that it absorbs chlorophyll needs as a building function for the plant. So this brown area actually got less red because there's more red that's being reflected off the plant. So it's not as healthy. So now it's 114. So you could go through here. Let's pick another plot. Here's the next good plot. Get it centered up where I want it. Hit F1, and there's the data for that plot. And then I could go through here, do another plot, hit F1, and here's the data for that plot. Okay, so that's a way that you can quickly get RGB data out of these imagery or the different wavelengths with a free program called ImageJ and get it into something that's quantitative. If you're a farmer, like I said, you may not be looking at plots, but you may have a whole field image where you see good and bad spots, and somebody asks, well, how much worse was that bad spot than the other bad spot? Well, you could make it quantitative with this method. So now let's do one other thing. So what do I do with this data? Well, one thing that we do is that we can copy this data, or you can save it, either one, to a text file. We can go over to Excel. That's a program that we frequently use that probably a lot of other people use. And I'm going to minimize this just so you can see everything. Put this down here, hit paste, and voila, there's our data. Now you're going to have to remember which plot you did, as you go from one end to the field, or somehow write that down or something. So now this data still is kind of in a format that's a little bit hard to use. I usually put things across the columns so I can do calculations as I go down instead of down the rows in this format. So what you can do here is you can highlight. Let's get the heading. Hit Control-C. We'll come over here, and I'm going to hit Transpose. Okay, so now I've got my headings going across the columns instead of down the rows. I'm going to go over here. I'm going to select this one because I know it's my first block of 5. Control-C, and I'm going to hit Transpose. So for me, and let's add one more column here because I want to add something in. Insert column. So for me, this might be plot 1. Okay. So the next bit of data, and you're going to have to remember to keep where you're at here, because this can get a little bit hard to do if you've got like thousands of this data going down the spreadsheet. You may even want to erase parts of it as you move it up. I can go to the next plot. Make sure you select 5 because that's where it ends. Hit Control-C, paste or transpose, and there's my data for plot 2. Okay, so let me just grab a couple of these other ones real quick, and then I'll show you how to get an indices calculation, which may be what you're really trying to get to with this quantitative data. So here's transpose, and here's transpose the next. Oh, now let me show you one thing. This is kind of nice. You see how I didn't stop to write the plot 1, 2, or 3, and I could see where I selected last time? That's kind of not nice to help you increment one down from where you were. Control C on this, transpose. Okay, so let's put plot 3, let's put plot 4. Okay, so when I get this data, you can leave this here or you can erase it, whatever. We don't really need it anymore. So, and I'm going to slide this over because I actually want it more over here. So I'm going to go Control X, Control V. Okay, so let's look at what we got here. We have the color values for the red, which we know is absorbed by healthy chlorophyll. This number gets lower as the plant gets more healthy and it's using up more of the red. We have the green, which is somewhat absorbed also, but not as much because it is reflected. And we also have the blue, which is actually sort of absorbed like the red, not as much, but it's a higher frequency, higher energy type wavelength, so it is absorbed also. So we have a red, green, and blue divided by 3. You don't really need that. You know, maybe it's useful, maybe it's not, I don't know. And then there's this equation 1 that somehow tries to convert this back to some other color space, a different color space than where we're at. I usually just use the original data, red, green, and blue values, so we're going to erase those. Okay, so now let's say I want to do an indices. You know, if you told somebody, well, this was the color for red, they're probably going to look at you like, that doesn't really mean much to me. So let's say I want to put an indices. And vary is a good indices. And if you remember, vary is green minus red over the sum of green plus red minus blue. And this stands for, I think, visual atmospheric ratio index or something like that. But it's an NDVI type reading for red, green, and blue type data. So let's type that equation in. So I'm going to put an equal. I'm going to put a parentheses because I want to do green minus red, which that's what it is for that equation. I'm going to put another parentheses because now I want to divide it because this is a normalized type data set type equation. And I'm going to say green plus red because if you look around on the internet, that's the equation for this, minus blue. And that's the proper equation. So now when I hit return, that's the value you're going to get. And this value could be anywhere from -1 to +1, kind of like normal green seeker type NDVI readings. Now I'm going to show you one more indices because we tend to have better luck with this one than we do with vary. The green minus the red, and I'm going to put VI because we'll normalize it. Sometimes I don't even do that. Sometimes I just take the green minus the red value and plot that out for all my plots. And this actually has a really good relationship, sometimes even better than the vary for us, to plant health and plant growth. So I'm going to say equals, parentheses, green minus red. And this one has the VI, which means it's been normalized. I don't always do that. Sometimes I just do green minus red and that's it. And especially if you have data with shadows in it. If you use the green minus red and you've got some shadows or something, you'll probably still be able to get at the plant data that's in there. If you do the normalized version, which is dividing by the sum of it to try and normalize each one, that'll cause you fits in data that has shadowing in it. So look at your data and see what works best. So now we're going to go green plus red, and that's that indices. So there's the value you get for that. So what we're going to do now is we'll copy these down, Control C, Control V, and there's my numbers. Now, if we had taken some other readings like green seeker or something like that, we would kind of actually know what this meant, but we don't. So let's do one other thing that may help us out to see what we got here. Insert a column, and we're, you know, this would actually be some scaling, but we're just going to say this was a good this was a good plot, this was a bad one. And if I remember right, this should have been a good one, and that should have been a bad one. So we'll just put healthy or not. Okay, where 1 is healthy and 0 is not healthy. So now we can go back and graph this. We can actually kind of see what we got. So we want this to be on the x-axis. So I'm going to copy this over here too, just to make it a little easier. You can always flip those other ways. And then I'm going to say, let's do the GRVI. Okay, so we're going to hit Insert, Chart. Voila, and there's what we got. Now you can see we're already forming a line. I can go through here and say add a trend line, linear, set the intercept. Doesn't have to go through 0. Probably won't go through 0 on this. Slide this over, and there's our data. So don't forget, the bottom axis here is the green minus red normalized index or indices, which in this case we've done a lot of data and it does indicate plant health pretty well. And then over here on this side, on the y-axis, is actually healthy plant is 1 and not healthy is 0. So you can see that kind of worked. Now if you'd done a bunch of plots, you would actually have data all the way through here. And we've actually done enough research to tell that the green minus red and the vary both are linearly related to NDVI red really well. So so they'll give you a linear relationship just like the others. Sometimes if you get in soybeans and it's like later in the season when they've really got full canopy coverage and they're that really dark green, this may tend to flatten out on you a little bit, and you may get just a little bit of a polynomial or sloped line. So, but it's still fairly linear. The reason we don't like it as well is it tends to do that more on the top. It really hits a flat plateau where it just flattens out. This one's a little bit better at not doing that. So anyway, that's how you get numerical data from your plots. And do remember, those plots can be single images, or they can be orthomosaics, either one. So whatever you can get into a program. I will give you one clue, and I'm not going to go over that right now. When you pull these images up, it's really nice if they're X and Y, or if they're horizontal or perpendicular for the boxing, as it does get hard to do a polynomial each time, or at an angle and stuff each time. So sometimes we will double click on this and take one of the Windows programs, do an edit, and actually rotate this back to being straight. And in another video, I may show you how to do that. It's not too hard, but you're just going to rotate this image and resave it as a rotated image where my rows and plots are straight across or up and down the photo. That allows you to do this box maneuver really well. Okay, well, if you have any questions, you can call me or send me email. My name's Randy Price. I work for the LSU Ag Center. You can look us up on their lsuagcenter.com website, or you can send me email, which is rprice@agcenter.lsu.edu, and I can answer some questions for you. Thanks. Y'all have a good day.